We can also, if we are at a particular node, we can also go down and get just the immediate children of that node. So we're looking at a tree. When you look at a tree, you can think of an element as having children, and then each child having its own children. So from a subtree rooted at an element, what we end up getting is a bunch of descendants of that subtree, right? Of that node. So given that we are at a particular node, we get a bunch of descendants of that node. So if we want the immediate children of a node, all we need to do is iterate over the root itself, or over the element itself. So here we say we're starting with the root of the tree. We say give me the children. So who are the children of root, which is in this case bookstore? The children of bookstore, that's our root, are book and book. And let's take a look at that. And that's what we get. Book at this, book at that. So we get 2 books there. For any element, given an element, we can access the tag at that element. So if I do, for let's say child in root, I'm going to get first this child and then this child, and I can get the tags associated with that. And it tells me they're book and book, right? That's we can see what the tag is if you want to do something with it, all right? So we got that. So now let's go and see if we can find the first name and author and last name of an author given an author tag. So what we're going to do is we're going to use our iterator. So that's the iterator that we had, root.iter. And we're going to say that instead of iterating over the entire tree, of course it's going to iterate over the entire tree, give us only the nodes or the elements that have author as their tag name, okay? Not all the other ones. And for each author as a tag name, we wanted to find the first name and last name associated with that author. And remember, these are first name and last name are also, if we have here, so what we're going to do is we want to go through our tree and we look for any tag that has the name author, and then we stop at that tag and say get me the tag first name and the tag last name that belongs to the author. And this is only going to look down at the children, at nothing else. It's not going to look at any descendants. In this case, there aren't any, but it's not going to actually look at descendants. So if we do that, we go back here and run this stuff. And then the last step here, of course, is we're going to say, give me the text associated with that. So now we are saying that for an author, find the first name and get the leaf text on the leaf for that. So we're actually getting data here. And similarly for the last name. So what this tells us is that what this will give us is all the authors in our XML tree. So we have 3 authors, Richard Barinholtz, Bill Harris, and Georg Brockman, and those 3 authors show up over here. So sometimes it's useful to know the structure of the tree, that is who the parent and what parent and child combination will produce a certain answer in the tree. For example, let's say I have this tree here again, and a part of my tree, instead of author, first name, last name, I also have here a title. And the title is a leaf that says, say, Mr. Bill Harris, right? So the title of a person like Mr., Ms., Mrs., whatever, right? So doctor, professor, all that kind of stuff. So if I have this, and if I look in my tree and I say find, do a root.iter, iterate over the tree, looking only for tags that have the name title on it, the tag has the name title, and I'm really looking only for the titles of books, I'm also going to get Mr. along with New York Deco and 500 whatever of New York, right? So that's not so great. But what I do know is that this, if I'm interested only in book titles, then the thing that I'm interested in is in the format book and title, this structure, right? Not this is good, and not the structure that contains author and title. This is bad, right? Okay? So what I want to do is I want to say, instead of saying find title, I want to say find the structure book / title. This structure is called an XPath, and XPaths are very useful because of exactly the reason that we've seen here. So let's take a look at how we can do that. And what we can do is we could say for element in root.findAll, So root.findAll is going to find all tags that match this XPath. Root.find will find one tag that matches, the first tag that it matches, and root.findAll finds them all. So this is root.findAll tags all the tags that match book.title and print element.text. So let's look at how that works. So here we have the same structure here. For element in root.findAll book/title, print element.text. So what this should print for us is all the books that we have in our setup here. It's looked for the book title combination and printed out the text that is associated with the node that has this book title combination. This is the bottom of this subtree or this XPath that you can think of. Okay. So let's say let's see if you can do this. Find the last name of all authors in the tree root using XPath. So let's go back to our diagram here just so that we have something to refer to. And here we see that to find the last name, then what we need is an author last name combination. We technically don't need that, but let's say we want to do that. So find all this using the XPath that goes up to last name. All right. So let's see if you can do that. Try that, and then I'm going to try it here. Pause this and try it. Assuming you've paused it and tried it, let's see if we can work this out. So for element in root.findAll, and now we want to give the XPath that takes us to last name. So that would be book/authors/author/last name. And then we can print element.text. And that tells us the last name of all those authors is Barinholtz, Harris, and Brockman. We've got 3 such authors there. We can also extract attribute values. We saw that in our tree, we've got a bunch of attributes. So book, for example, has an ISBN number, a price, and a weight. And we want to extract these values as well because this is data as well, right, for us. That's pretty straightforward. All you need to do is when you do root.find, so remember find will return just one item, not all of them, the first item that it finds. You give the thing you're looking for, book, or the XPath or whatever. And so we are looking for, here we have an entire XPath actually. So we got this entire XPath, and we are saying in our XPath, because this was going to technically return, in our case it'll return only one, but if we had find all, it will return many of them. We want to say that only those books that have a weight of 1.5, whatever 1.5 is. So the way to specify that is to put in square brackets and then at the rate of the name of the attribute followed by equal to followed by the value of the attribute. So this gives us the value of that book, and that's the author's first name for the book that has a weight of 1.5, which we can see in our tree is this one here, right? So if we can go back up one, here we see that in our tree that the book with a weight of 1.5 has an author with first name Richard, and that's what we end up seeing in this place here. Richard, okay? So we've done that. So now as a final exercise for this class, what you want to do is see if you can find the first and last name of all authors who live in New York City for the tree that we have over here. So note that in our structure, and I'm not going to do this for you. You can try this. The answer will be posted online. In our structure over here, we have authors has an attribute called residence, and that residence is New York City here. So what we want to do is we want to, from our data structure here, we want to pull out the first name and last name of this author and the first name and last name of this author. So what we should see is 2 lines. The first line should say Richard Barinholtz, and the second line should say Georg Brockman. That's it. Thank you.